Hi friends, welcome back. Today we'll go through another interesting AIML uh, topic called pipelines. So we will be trying to create custom pipelines, simple custom pipelines. We are not using the Hugging Face pipelines that are predefined in their functionality. We'll use the um, basic sklearn pipeline. So, what we have here is a supervised classifier. We use KNN and KNN here. We are also using SVM support vector machine. Basically, when we are using the iris dataset, the simple sklearn dataset. So we import the necessary libraries and then we load the iris dataset. And here, as you can see, the data consists of flower related information, which is the petal length, petal width, sepal length, and sepal width. And to basically display the columns, we need to extract the data from the iris data, iris target array, and iris feature names, and create the column names from the iris feature names, and also uh, display the species based on the target type, like 0, 1, 2, 3. So there is a target array, target names array. Based on the target type, it will return the species, which is Setosa or any other species. So this is the actual data that is there with the column names. Now what we will do is we'll split the data into training and test set in 70:30 ratio, and we are creating a simple sklearn pipeline that does standard scaling. Basically, scaling means converting all the data, whatever we see here, into a standard uniform measurement unit. Basically, by mistake, some of the width is in meters or some of the width is in inches. So it will standardize all that data into a proper unit, a standardized unit, and then uses it. Basically, it helps in the machine learning algorithm in converging the it faster or making it more efficient in simplistic terms. So what does a scalar versus normalization, what is the difference? So if you take any traditional supervised learning algorithm like logistic regression or SVM, basically any data that is supposed to be in a normal distribution. So most of the data that we have today is generally we observe that it is in normal distribution or Gaussian distribution. So such kind of data we apply standard scalar. So basically what does a standard scalar do is, for this we can refer a third party site. So standardizes the feature by subtracting the mean. It subtracts the mean and divides by, and then scaling to unit variance. What does this unit variance mean? It divides it by the each value, each feature, it will divide it with the standard deviation. First it subtracts the mean and then divides by standard deviation, and it helps mostly in data where it is normally distributed. So that is the standard scalar, and that's why we are using standard scalar here. And there is something else called normalization, which we see in neural networks. Because neural networks operate on data that are not normal distribution, we use normalization there. So one example of this normalization is min-max scalar. Going back to this is called the z-score also. This standard score is also called z-score. When you divide the each feature value with mean and divide by standard deviation, it's called z-score. Now going back to normalization, where we use in a non-normal distributed data, like the data like image data or that we have in neural networks. Oh, so here what they do is one of the examples is a min-max scalar for that. So they divide the feature value with the minimum value, and then they subtract the feature value with the minimum value and divided the maximum feature value with the using the minimum feature value. So this is about standard scalar and normalization. That's the difference. So here, because the data is supposed to be normally distributed, we are using standard scalar, and we are using two different pipelines. So basically this pipeline will standardize the data, then apply the principal component analysis. The basically it's a feature engineering thing where they set the number of features, optimal features, as 2, and it uses the regression k-neighbors classifier algorithm to predict the target, train the data, and then uh, it is used to generate the model. And then we have another pipeline which again standard scales the data and then applies the principal component analysis, feature engineering, and then uses this support vector machine, fits the data with the support vector machine algorithm. So we have the two pipelines in an array, and then we iterate through the pipeline and fit the data and predict the score. So here you fit the data on the pipeline, the individual pipeline items, and then you display the score. As you can see, it is predicting as the SVM has higher score on top of a k nearest neighbor. So that's about it today, friends. We in this particular it's a small tutorial. We learned how to do a basic sklearn pipeline, and also we have learned the difference between standard scalar or scaling and normalization. So basically scaling, we know that we need to apply on normal distributed data, and when the data is not normally distributed, like if the data anything related to money or anything like the roll of a dice, which is a binomial distribution, or anything related to neural networks, we can go with normalization. Basically what normalization does is it brings the data to a normally distributed format. So that is the reason the name is normalization. So that's about it for this tutorial, friends. Please don't forget to subscribe and like, and see you very soon in a different tutorial.